Welcome back. So, in the last video we have learned how to detect contours, and in this video I will show you how to detect circle and the image. So I will use an algorithm named Hough transform, but let's see, circle. So we use Hough transform to detect like circle or line in the image, and detecting circle can be used for many purposes, such as crane detection that we will use here, and any circle object, or even environmental application such as white blood cell segmentation or anything else where there is a circle, so we can use Hough transform like Hough circle to detect them. So basically, detecting circle and image follows some steps as initialize the image, apply blur, grayscale, and edge detector method, pick a point on the image if you know, and fix potential value, and you can vote to pick the best accumulator matrix that has the maximum value, and so many things. And you can find circle which are the maximum voting candidates. But OpenCV again come with a sample function that we can do to detect circle and the image, and the function do everything that we said before for us. But the function takes also some parameters to complete the task. By example, we have the image. Of course, we have to pass the image in order for the algorithm to know which image you want to detect circle in, and we use a detection method. For now, the only one which is in use is hard gradient. I will show you. And we have DP or main list, parameter 1, parameter 2, main radius, and max radius. So let's stop talking. Yeah, let's start coding. So import cv2 as cv, again numpy as numpy, and stop with the importing image cv dot image. Again, everything I need to do, I have to know the image before, and then and that's another function you learned for now. Read color. I mean, you don't want to work with grayscale image, and we can convert it to gray. cv2 cvt color and the image, and cv2 and color bgr to gray. Yeah, this one. Yeah, so we can blur, oh, let's call it like that, gray blurred. So yeah, another function that you will learn for now. It's so simple. We can blur the image, like just use cv blur the image or the gray one, and we add a kernel value 3 again, kernel value. It's like kernel value. You can read about it if you want. So let me show you the image for now. cv imp show the name of the window, and the gray blur. Yeah, and cv wait key, see, destroy all windows. Yeah, let me show you. Oh, again. Yeah, resized. CV, resized, image, and yeah, so hope it works now. Yeah, I don't know if you can see it. You can see that the image is a little bit blurred. So if I add a bigger value, yeah, you can see that. But if I just show the gray image, you will see without blur. Yeah, you can see the difference clearly. So this is a new function for you guys. So let's just copy this and continue with the detection. So we use the gray image because with Hough transform work with gray image, and to better, like, to filter the image to, in order to not detect it, yeah, in order to detect a real circle, not anything on the background like you see before when I detect contours. So I blur the image so I can, like, smooth the background. So let's continue with the code. So I can add detected circles, CV2, hard transform, Hough circle. Yeah, you can see the parameters that I said you before. The image, method, or gradient, DP, and etc. etc. So I use this one. So the image, remember that we use this image, bold one. So the method will be gradient, and DP, let's try 2.2, and the mean distance, let's try 100, and param 1, let's try, this is the threshold value, and param 2, so many times it seems to be, or it should be, the half of the first parameter. So you can read the I already have this main radius. You can read the theory about it, as I said before, and max gradient, max radius, see 0. So with this we detect circle, but we can add a statement or if statement to write something to practice. So let's try if detected circle is not none. Let's put the image, or put this, let's get the radius of every circle. Let's know the points. So we will use numpy finally. Detected circle, we convert it to numpy. UI 16. Yeah, it's a lot of code around detected circle. Yeah. So for I in detected circles, so we don't know how many circles will be detected. So I can add from the first one, which has index 0, to either now to all of them. Yeah. When I add the semicolon or the colon, it's mean to all of them from 0 to etc. So A, B, R, that's my point. We can add I0, I1, and I2. That's my points. So CV2 circle, remember this function, we add it to the image and not to the image that we blurred, but to the normal image, or this one, that it's like a copy, because the images are the same. When I detect circle on this image, they have the same points with the image, so I can detect them and this image and put them in the preview or the original image, and you can see the effect without blur. So I will put it here on the image, and we add the points A and B and the radius and the color. Yeah, we have 0 to 55 or whatever else you want, and thickness. So I can show the image in CV2, in show name, detected circle, and the image. Yeah. So CV2 weight key, CV2 destroyed all windows. Yeah, I can leave it like that, and I will show you after. Hope it works. Yeah, just one circle. I don't know why, but I will let you know. Yeah, it's good for me. Yeah, I didn't close the loop, that's why. So, not a good try, because the circle are detected after I click on a point, because of this function weight key. So I have to close this indentation or remove the indentation, and you can see right now all my circle. Not really good one, but you can see that the function detects them. So if you want, we can also draw the radius of the circle, like CV2. We can add a very small circle to the image again, the point A and B again, and now instead of adding the radius of the circle, we add just one as radius, because a circle could have radius like 10 pixels, and another circle could have radius like 20 or 100 or whatever. So when we add R that we get from the detected circles, we have the correct radius of each images. But when I add 1 here with the point X and Y, so it will be in the center of the image. So let's add a color for that. Yeah, let's say 0, 0, and 255, and then the thickness I can add 3. so it can be a little bit bigger. Yeah, so yeah, you can see this is the radius of this circle, 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 etc., etc. Let me try another image, like our user. So yeah, it finds just one circle with this point as radius. Yeah, if you want, you can take a rule and try it. Yeah, it's a joke. Okay, so I hope you understand how transform in Hough transform algorithm or Hough circle and how we can use it. So see you in the next